Welcome my dear students. So today in this session we are going to see about the application of dimensional analysis. So how to convert, one of the application is how to convert a physical quantity from one system of unit to another system. That's what we are going to see. Okay, so for converting a physical quantity in one system, from one system to another system, we have to follow a fact that suppose if I write 1 meter is equal to 100 centimeter. So it's correct. 1 meter is equal to 100 centimeter. If I measure the length 1 meter and also if I measure the length 100 centimeter, both will give the same measurement only. Okay, both will be same. But I have written this in meter and this in centimeter, but the length is same. So this can be written as N1. N1 means this numerical value. Okay, into U1. U1 means the unit is equal to N2 into U2. That is the product of the numerical value of a quantity and its unit in one system will be equal to the product of the numerical value and its unit in another system. So in general we can say Nu is equal to constant. Okay, so by using this equation, that is N1 U1 is equal to N2 U2, we are going to convert the universal gravitational constant from one system to another system. Okay, so this is an example problem given in your book, that is if the value of universal gravitational constant in SI is, so in SI system it's given 6.6 into 10 power minus 11. The value of universal gravitational constant in SI system is given in the question. Okay, Newton meter square kg power minus 2, and we have to convert it in CGS system. So from SI system we have to convert it into CGS system by using dimensions. Okay, so first write what is given. G in SI is given as 6.6 into 10 power minus 11 nm square kg power minus 2. We have to convert this into CGS system. So CGS is what we have to find. Okay, so SI system value is given. We have to find that value of G in CGS system. Okay, so for that consider this is the first system, that is SI system, and the second system is CGS system. In this SI system, the length is measured in meter, mass is measured in kilogram, and time is measured in second. Okay, so we can write it as M1 is equal to 1 kg. Likewise, L1 is equal to 1 meter and T1 is equal to 1 second. Okay, so MKS. So mass is measured in kilogram, length is measured in meter, and time is measured in second. So this is system number 1. So I am using the number 1 here. So in the second system, how can we write it as M2 is equal, here listen, the mass is measured in grams. So I had to write it as 1 gram. Length L2 is equal to centimeter. So 1 centimeter. And time T2 is equal to 1 second. Okay. So then we are going to derive that. So here for that I am going to use this equation. N1 U1 is equal to N2 U2. So for our convenience we can write it as N2 U2 is equal to N1 U1. N2 is the numerical value of G. Okay, so in the second system, so it is G CGS into U2. U2, here the unit, and here I am going to write the dimensional formula for G. Okay, so for that write it as M2 L2 T2. We don't know the powers. Okay, so we have to take it as A, B, C, which is equal to N1. N1 is the numerical value of G in SI system. So GSI into u1. For that we have to write the dimensional formula. So m1 L1 T1 power A, B, C. Okay. So if you are writing the first system, we have to denote by 1. If we use the second system, that is CGS, we have to represent it by the letter 2. Okay. So from here, GCGS is equal to, we can write it as GSI into M1 power A, L1 power B, T1 power C by, this comes down, so it is M2 power A, L2 power B and T2 power C. So in the next step, GSI into M1 by M2 the whole power A. So the M terms are written in one square bracket. Likewise, the L term we have to write in another square bracket. So L1 by L2 the whole power B and then T1 by T2 the whole power C. In the next step, we have to substitute all the values. Okay. So we know these values, GSI, it's given in the question, M1, M2, L1, L2, T1, T2. All the values we know. So we have to find only this A, B and C. So how to find this A, B and C? For that we have to write the dimensional formula for this G. So how to find the dimensional formula for G? So we know the force of attraction between any two bodies, F is equal to G into M1 M2 by R square. So F is equal to G into M1 M2 by R square. From here, what is G? G is equal to FR square by M1 M2. So apply the dimensions. What is the dimensional formula for F? ML T power minus 2 into L square by, for mass it is M square. So one M gets cancelled. So you'll get this M goes up. So it is M power minus 1. L into L square, it is L cube. T power minus 2. Okay. So this is the dimensional formula for G. So from here I can write the value A is equal to the power, no, this is A. A is minus 1. B is 3. And what is C? C is minus 2. Okay. Now I am going to substitute here. So what will I get? GSI. GSI, the value is given here. It is 6.6 into 10 power minus 11 into, what is M1? M1 is given as 1 kg by, what is M2? 1 gram. The whole power A. What is our A? Minus 1. What is L1? L1 is 1 meter by 1 centimeter. The whole power 3. And T1 is 1 second. T2 is 1 second. The whole power for C we have to write minus 2. Okay. So now in the next step, I am going to convert this kilogram to gram. Or you can convert this gram to kilogram. Both we can do. So now how to convert this kilogram to gram? So for that I can write GCGS is equal to 6.6 into 10 power minus 11. Here I can write, instead of 1 kg, it is 10 power minus 3 grams. Okay. 1 kilogram is equal to 10 power 3 grams. Instead of 1 kg, it is 10 power 3 grams by 1 gram. The whole power minus 1 into 1 meter is equal to 100 centimeter. So it is 10 power 2 by 10 power 2 centimeter by 1 centimeter. The whole power 3. Here 1 second and 1 second gets cancelled. So 1 power minus 2 is 1. Okay, so no need to write that. 6.6 into 10 power minus 11. Here it is 10 power plus 3 the whole power minus 1. So it is 10 power minus 3 into 10 power 6. So which is equal to 6.6 into 10 power minus, so here minus 11 minus 3, so it is minus 14 plus 6, so it is minus 8. Okay, then we have to write the unit. So here in SI system it's written as Newton, the unit of force is Newton. In CGS it is dyne, and here we have written meter square, so for that in CGS centimeter square. It's kg, so here it is gram, the whole power minus 2. So what is this? G CGS. Okay, so we have converted the value of G from SI system to CGS system. So for SI system it is 6.6 into 10 power minus 11, and we are getting in CGS as 6.6 into 10 power minus 8 dyne centimeter square gram power minus 2. Okay, so hope you have understood how to convert a physical quantity from one system to another system. Okay, so meet you in the next video. Until then, it's bye from Anandi. Bye.